So going back to page 3, we talked about multiplicity of zeros. We talked about multiplicity being the number of times a zero appears, which actually ends up being the power on the factor. What goes along with multiplicity is on a graph, which is what's coming up now, is that I can tell what the graph is going to look like at that zero by its multiplicity. So if the graph is if the zero is multiplicity 1, the graph crosses the x-axis, looks like a straight line. So in this case we can say it looks like a line and it crosses the x-axis. So a line crosses the x-axis. If it's multiplicity even or multiplicity 2, it is a parabola at that zero. That's what it looks like at that zero. It's a parabola, and you notice that it doesn't cross the x-axis. This touches the x-axis. And if it's multiplicity 3, 5, 7, 9, it looks like an S-curve, but you notice that it also crosses the x-axis. So what it's telling me is that multiplicity odd, 1, 3, 5, 7, 9, etc., the graph will cross the x-axis. If it's multiplicity even, 2, 4, 6, 8, the graph looks like a parabola at that zero, and it touches the x-axis. Now that is exceedingly important to us when it comes to 3, 6. Everything we're doing is leading to 3, 6, which is about a third of calculus, by the way. About a third of calculus. Okay, so let's go to what they're talking about here. If I take a look, and we're going to fill in the chart, and we're now on page 5. I look at, it's 4 times x plus 4. X plus 4 is degree 1. So 1, and x plus 3 is multiplicity 3. It's got the power of 3. If I'm looking for zeros, that's where I'm going to take 4 times x plus 4 times x plus 3 cubed, set that equal to 0. So then I can say that my zeros are x equal negative 4, x equal negative 3. So my zeros are negative 4 and negative 3. What is the multiplicity of the zeros? Well, x plus 4 is a power of 1. So that means that x equal negative 4 is multiplicity 1. Why? Because the power on the factor is 1. X equal negative 3, this tells me that x equal negative 3 is going to be multiplicity 3. Well, why? Because the power on the factor is 3. We look at, does the graph touch or does the graph cross? Multiplicity odd, this is 1. It looks like a line as it does what? Crosses. Multiplicity 3, it looks like a what? S as it crosses. Now what's the power function? Now the power function is the guy who is in control. He's the controller of it all. The power function is gotten by leading coefficient is 4. What's the highest power of x that comes out of x plus 4 to the 1 power? X to the 1. What's the highest power of x that comes out of x plus 3 to the 3rd power? 3. If I multiply that together, 4 times x to the 1 times x to the 3, that's what comes out of all of those factors, this becomes a 4x to the 4th. That's the power function. Now, what does that give me? And this is the extras that's not in your book that we're going to add as we go along anyway. I know that the leading coefficient that's of the power function is 4. And I know because of the power function, the degree is what? 4. Because the power function ends up being the term with the highest degree, highest power. Now, what about, I know this now, what about in behavior? Degree even is what? It's top, top, bottom, 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 top, top, bottom. The degree even is always the same direction, like x squared. If the leading coefficient is positive, it's either top, top, or bottom, bottom. What is it? Top, top. That says, I don't know what it does in the middle, but I know at the ends, it's that. And then it does stuff here. It does stuff in between. Don't know what it does. Actually, I will know what it does shortly. But it does stuff in between, but I know that it's going to come in from the top, do its thing, whatever it is, and go out through the top. So it's top, top. Notice I did not calculate one coordinate point on that graph other than the x-intercepts, and I now pretty much know what this guy's going to do. Okay, remember we're finding the zeros, so this is x minus 1/3 the quantity squared times x minus 1 cubed equals 0. So we're going after the zeros. That means that x equals 1/3, x equals 1. Notice it's already in factored form. That's what's nice. So my zeros are 1/3 and 1. And what's the multiplicity of 1/3? 2. So this is multiplicity 2. Does it touch or cross? Touch, because it's multiplicity even. And x equal 1 is the other 0. What's its multiplicity?
3.
Multiplicity 3. Does it touch or cross? Cross, because it's odd. Now, what is the power function? Well, if I look at the power function, the highest power, I've got a 1 sitting in front, so that's my leading coefficient. The highest power coming from x minus 1/3 squared is what? X to the 2. The highest power coming out of x minus 1 to the 3 is x to the 3. The power function is 1 times x squared times x cubed, which is 1x to the 5th. That is the leading term.
You really don't need the 1, do you?
No, you don't need the 1. But it's there. Well, what are the extras? What's the leading coefficient? The leading coefficient is 1, which is why I put it there. You don't have to have it there. And so what is the degree? What's the degree?
3.
5. What's the end behavior? End behavior, I have an odd degree polynomial. An odd degree is O is odd, O is opposite. So that means that I am looking at a leading coefficient of 1, which is positive. So it's either bottom top or top bottom. Not top bottom.
Bottom bottom?
That's the opposite.
It's got to be bottom top. Alphabetical order. When there's a minus there, it's going to reverse the order. So think about it's going to be an alphabetical order if you're looking at a positive leading coefficient. So that means it's bottom top. That means it comes up from the bottom, does its thing, and goes out through the top.
So if that was -1, it would be top bottom.
It would be top bottom. It reverses the order.
Okay.
So BT, TB. Bottom top. Once you know it's odd, which means opposite. So that means that it's either BT or TB.
When it's opposite,
It's either BT or TB. Now, if the leading coefficient is positive, it's alphabetical order, so it's BT. It's in straight order. If it's negative, then it does everything. Remember, negatives, leading coefficients flip around the x-axis. That means it's going to flip it from then top bottom.
So the previous one, if it was a degree of a positive number and it was smaller than 0, it'd be bottom bottom.
No, it's negative or positive. What you're looking at is vertical stretch, vertical shrink, when you're looking at leading coefficients that are fractional. Now, that's the other thing. There's no vertical stretch shrink on this guy because the leading coefficient is 1. Leading coefficient being 4 here says I have a vertical stretch, a vertical stretch factor of 4. Remember with the quadratics when we completed the square, what did we factor out? We factored out the leading coefficient. So that leading coefficient is telling me vertical stretch, vertical shrink. Because I could factor it out just like I would do anything else. So this guy basically is going to be stretched this direction. This guy down here is going to be regular size. So the leading coefficient, positive, negative, is what gives us end behavior, not at all the idea of vertical stretches or vertical shrinks.